In this video, we'll discuss the design of keys. Key is basically used to connect the two rotating members. As you see here, we have a shaft here and we have a hub, and groove is made in the shaft as well as in the hub, and the key is inserted between the hub and the shaft, and the final assembly will look like this. Because of this, there is a temporary connection between the shaft and hub, and when the shaft will rotate, the hub will also rotate. So we can define the key as a piece inserted in the axial direction between the shaft and hub, such as a pulley or a gear, etc. These keys are temporary fastening and are made up of MS, that is a mild steel, because they are subjected to the shearing and the crushing. The shearing strength is normally less than of the crushing stress. So we know that we have shearing stress, which is represented by tau, is less than the crushing stress sigma CR. Hence, in the assembly of the key, shaft and the hub, the weakest member is the key, so that the shaft and pulley are always safe. In this video, we are going to discuss the function of key, then the types of key, failure modes of key, design of key based on the crushing strength and the shearing strength, and then we'll clear our concept by taking some tutorial problems. So a key can be defined as a machine element which is used to connect the transmission shaft to a rotating machine element, either a hub or a boss, like pulleys, gears, sprockets or flywheels. It is always inserted parallel to the axis of the shaft, and the keys are temporary fastening and are subjected to considerable crushing and the shearing stresses. So for manufacturing the key here, we require a very small material as compared to the shaft and hub, and therefore if the key will fail, we can replace the key. But if the shaft will fail, the cost will incurred is higher. So in the case of assembly of a pulley, key and a shaft, the weakest member is a key, so that the key will fail and the shaft and pulley are always safe. So we can say here that a key acts as a safety device for the shaft and its assembly. And because of the lower cost, it is cheap and easy to replace. So basically the keys are introduced between the shaft and the hub assembly or pulley assembly, and the primary function of the key is to transmit the torque from the shaft to the hub of the mating element and vice versa. The second function of the key is to prevent the relative rotational motion between the shaft and the joint machine element like gear or pulley. So we have two functions of key. One is a primary function which is used to transmit the torque from the shaft to the hub, and in the secondary function it prevents the relative motion between the shaft and the gear or pulley. Now we'll discuss here the type of keys. There are number of keys are used. We'll introduce one by one key. So there are various types of keys are used, like sunk keys, saddle keys, tangent keys, round keys, splines, and the Kennedy key. The keys are basically classified on the basis of the low and the medium duty keys, or they are classified as heavy duty keys. In this case, the tangent key and the Kennedy key as well as the Barth key are the heavy duty keys. So tangent keys and the Kennedy key as well as the Barth key are the heavy duty key, whereas the sunk key, saddle key, round key and the feather key are normally the low and the medium duty keys. Total there are 6 types of sunk key. First one is the rectangular sunk key, because the shape is a rectangular one, therefore it is called as a rectangular sunk key, in which the width is more as compared to height. Second one is the square sunk key, in which the cross section is the square, width and height are equal. Then we have parallel sunk key. Then we have a jib head. The head is provided for quick removal, which one is called as the jib head keys. Then we have feather, so 2 jibs are provided in the case of feather sunk key. And finally we have wood rub key, which one is a semicircular in cross section. Saddle keys are basically of 2 types. One is a flat saddle key and second is a hollow saddle key. So we'll discuss these keys in the same sequence that we have written here. First we'll discuss the sunk key, that is a rectangular, square, parallel, jib head, feather and the wood rub. Then we'll discuss the saddle key, tangent key, round key, splines, Kennedy keys. After that, we'll go for the design of the keys. Selection of the key is based on the power transmitted, whether we have low power transmitted or medium power transmitted or very high power is transmitted. According to that, you have to select the saddle key, sunk key, feather key, or the splines or the Kennedy key. Then depending upon the tightness of fit, whether we want the loose fitting or tight fitting, we have to select the key. Then the stability of connection, and finally we have the least cost involved in designing the keys. In the case of saddle key, we have a shaft and hub. In this case, the keyway is made only in the hub, not on the shaft. And if it is a flat saddle key, then the flat keyway is made in the case of hub. And in the case of the hollow saddle key, a concave type of keyway is made in the case of hub. So saddle key is a key which fits in a flat keyway of the hub only. Hollow saddle key has a concave surface at the bottom to match the circular surface of the shaft, and in the case of a flat saddle key has a flat surface at the bottom and it sits on the flat surface machine on the shaft. In the third figure, you can clearly visualize the key surface is adjusted with the shaft surface, so it has the same radius that of shaft on the bottom and is a concave in shape. In the case of saddle key, power is transmitted due to the frictional forces developed between the shaft and the key surfaces, and they are normally used for low duty. So in both type of saddle key, that is a flat saddle key and the hollow saddle key, the friction between the shaft, key and the hub prevents the relative motion between the shaft and the hub, and the power is transmitted by means of purely friction. These saddle keys are suitable for light duty or low power transmission as compared with the sunk key. The second type of key is the sunk key. In the case of the sunk key, we have a shaft, hub and the key. Either we have a square cross section or we have a rectangular cross section. In the case of a square sunk key and the rectangular sunk key, the key in which half the thickness of the key fits into the keyway on the shaft and the half, that is the remaining half, in the keyway of the hub. Therefore, the keyways are required both on the shaft as well as on the hub, that is of the mating part. So you have to make here the keyway both in the shaft as well as in the case of hub. In the case of saddle key, the keyway is made only in the hub, not on the shaft. That is the basic difference between the saddle and the sunk key. Here also the power is transmitted due to the shear resistance of the key. The relative motion between the shaft and the hub is also prevented by the shear resistance of the key, and the sunk key hence is suitable for heavy duty applications since there is no possibility of the key to slip around the shaft. These keys are further classified as the rectangular sunk key, which has a rectangular cross section, and we have a square sunk key, as well as the parallel sunk key, jib head key, feather key and the woodruff key. So in the case of a sunk key, power is transmitted due to the shear resistance of the key. The relative motion between the shaft and hub is also prevented by the shear resistance of the key. This type of keys are suitable for heavy duty applications since there is no possibility of the key to slip around the shaft because the keyway is made in the shaft as well as in the hub. In the case of rectangular sunk key, we have shown the two view, the side view and one is isometric view. In the case of rectangular sunk key, the width is higher as compared to the height h. In this case, if d represent here the shaft diameter, then the width of the key is w and the width of the key is taken as d divided by 4, and the thickness of the key that equal to h is normally taken as 2/3 of the width, 2/3 of width. That is same as equal to 2/3, but width is equal to d by 4. So 2 and this 4, 2 becomes here. So we have thickness of the key is same as equal to d by 6. This key has provided a taper, that is the value of theta. Tan theta is 1 by 100. And this taper is provided only on the top side, not on the bottom side. So only on the top side you have to provide a taper of 1 in 100. Similar to rectangular sunk key, we have a square sunk key. The only difference between the rectangular sunk key and the square sunk key is the cross section of the key. In the rectangular sunk key, we have rectangular cross section where width is greater than the thickness. But in the case of the square sunk key, we have a width and the height are equal. So in this case, the width of the key W is same as the thickness of the key, that equal to h, and is same as equal to d by 4. So in the case of the rectangular sunk key and the square sunk key, we are providing a taper here of 1 in 100. Similar to this, we have parallel sunk key. The difference between the parallel sunk key, rectangular sunk key and the square sunk key is that they are the taperless, having a rectangular or again a square cross section. Almost similar concept of a sunk key, but this time we have parallel sunk key in which the taper is not provided, whether it is a taperless, having a square cross section or a rectangular cross section. Now since no taper is provided, it means that a rotating element is required to slide along the shaft. So parallel sunk key, either square type or rectangular type, is used when the rotating element is required to slide along the shaft. Now since here no taper is provided throughout the length L, so thickness will remain constant. So it has a uniform thickness throughout, as well as the width is also uniform. So in the case of parallel sunk keys, maybe rectangular or square section uniform in width and the thickness throughout. But if you observe the rectangular sunk key in which we have provided the taper, the height will also change. Height is h and this height is increased to capital H. It may be noted that a parallel key is a taperless and is used where the pulley, gear or other mating piece is required to slide along the shaft. That time you can think of the parallel sunk key. Then we have a jib head key. As we know that in the case of sunk key, the groove is always made, that is, a key slot is made in both, that is in the shaft as well as in the hub. So we can visualize here the keyway is made both on the shaft as well as on the hub, and this one is a jib. This one is called as jib head. The key has a width is equal to W, height is equal to T, that is same as equal to H. The height of the jib head is taken as 1.75 times the thickness of the jib, and the taper is also provided as 1:100. So this jib is inserted in a key slot, and finally we'll get this arrangement where we have the shaft and the hub is connected by jib head. So this one is same as the hub and shaft, and we'll find here we have a jib head key. So this type of key has a rectangular cross section and we have a head provided in the case of jib head. It is normally provided to facilitate the removal of the key, and we have usual proportion is width is taken as d by 4, thickness at the large end is t is equal to 2 times of width divided by 3, which is same as equal to d by 6. Now here the taper is provided in the case of jib head, and in the case of feather key the taper is not provided. The next type of key is the feather key. Feather key are basically the parallel key which are fixed either to the shaft or to the hub, and it permits the relative axial movement between the shaft and the hub and prevents the relative rotational movement between them. So axial movement is allowed, but the relative rotational movement is restricted. In this case we have feather key is shown. This one is a flat surface and we have head on both sides. This is the keyway is made on the shaft, no keyway is made on the hub. So when this key is inserted in the keyway, then we get a final assembly as shown in this figure. So key attached to one member of pair, that is in this case we are taking the shaft, and this permits the relative axial moment known as a feather key. It is a special type of parallel key which transmits a turning moment and also permits the axial moment. It is fastened either to the shaft or either to the hub, and the key being a sliding feet in the key way of the moving piece. Sometimes the feather key is screwed to the shaft, or sometimes the double jib heads are provided on the feather key. The proportions of the feather key are same as the rectangular sunk key and the jib head key. So dimensions are same as compared to the jib head key and the rectangular sunk key. So in this figure we'll find here, if the heads are not provided, then the screw are provided, that is the set screw are provided. Otherwise the jib heads are provided in the second figure. So because of the set screw provided and the jib head provided, and we find here that the width is more as compared to the width of the pulley. So axial relative moment is possible in the case of feather key. Next type of key is a Woodruff key. It is a segment. This type of key is used. It is a segment form a cylindrical disc. A keyway in the shaft in the form of semicircular recess with the same curvature that of the key. Hence the shaft will become weak because the depth is more as compared to rectangular sunk key. This type of key is normally used for angular misalignment, and hence it is called as self-aligning key. It is most commonly used in automobile and the automatic lathe. So the keyway is made here of a same shape, that is a cylindrical type of disc. So that is a semicircular recess is made, then the key is inserted and the hub is then inserted. Finally we'll get the assembly. The two-dimensional figure you can visualize here. We have a semicircular disc of radius equal to r. Now this key is a easily adjustable key, and it is a piece from a cylindrical disc having a segmental cross section that you can visualize in this figure. This Woodruff key is capable of tilting in a recess milled out in the shaft by a cutter having the same curvature of the disc from which the key is made. This key is largely used in a machine tool and the automobile construction. The advantage of the Woodruff key that it accommodates to any taper in the hub or the boss of the mating piece. Secondly, it is useful on the tapering shaft ends. Its extra depth in the shaft prevents any tendency to turn over in its keyway. Since here the semicircular recess is made in the shaft, so the cross-section area will going to reduce. Because of this, the depth of the keyway weakens the shaft and it cannot be used as a feather key. That is, the axial moment is not possible, but the radial misalignment is possible in the case of Woodruff key. When we require to transmit very large power, in that case we have to use the tangent key. Tangent key is shown in the figure. Basically it consists of two keys, key 1 and key 2. Together it is called as tangent key, and the slots are made at an angle equal to 90 degree. In this slot the key 1 and 2 are inserted. So in this rectangular slot the key is inserted, that is either portion 1 or 2 is inserted. So here the portion 2 is inserted. So you will find here the key is inserted in the recess. Then the second part of the key is inserted in the given key recess and you get a final arrangement here. So there are basically two keys and other key recess is made at an angle equal to 90 degree to each other. After assembly you will find here there are the two keys inserted at an angle equal to 90 degree to each other. The tangent keys are fitted in a pair at right angles as shown in this figure. Each key is to withstand torsion in one direction only, and this type of keys, that is the tangent keys, are used in a large heavy duty shafts. Another type of key which is normally used for low power transmission is the round key. Round key is called because we have a circular cross section of the pin. So in this case the half key recess is made in the shaft and the half key recess is made in the hub. Then the key is inserted in the recess and we will get a final assembly as shown in this figure. Key may be of uniform diameter or it may have a tapered pin also. The tapered pin is held by friction between the pin and the rim tapered hole. So either we use the uniform cross section or we use the tapered type of pin in the case of round keys. Splines. The splines are inbuilt keys which are formed by shaping the outer circumference of the shaft and the inner circumference of the hub as shown in the figure. So these are the built-up keys. Number of keys are used on the inner circumference of the hub and the outer circumference of the shaft. Each of them has a tooth-like a structure that is similar to gear. The power is transmitted equally and divided among the number of keys, giving a great strength and the security against the total failure using a single key. So basically the splines are nothing but a number of keys which are made integral with the shaft which fits the keyway brooch in the hub. Such shafts are known as the spline shaft. This shaft usually have a 4 as shown in the figure, or we have 6, 10 and 16 splines. The spline shafts are relatively stronger than the shaft having a single keyway. The spline shafts are used when the force to be transmitted is large in proportion to the size of the shaft, as in automobile transmission and the sliding gear transmission. By using the spline shaft, we obtain the axial moment as well as the positive drive is obtained. The spline shaft that you are familiar is normally used in the two-wheeler at the kick. So the kick is mounted on the spline shaft. Kennedy keys are normally used for very heavy duty. It consists of two square keys which are mounted in the shaft. For this purpose we have to make here the two square races, half in the shaft and half in the hub. In these two races we have to insert here two Kennedy keys. This figure represents the final assembly. So Kennedy key consists of a two square key which are mounted in the shaft and they are commonly used for heavy duty. So if you want to transmit the very heavy power, in that case we can think of the Kennedy keys. So exactly in the front view you will find the key is inclined at an angle of 45 degree. This one is an enlarged view in which we have a side of a square is equal to B. So this side is equal to same as equal to B. The sharing will take place approximately at this cross section, which one is the common cross section to the shaft and hub. And what we observe is that in this case the area will going to increase. So this dimension will be same as equal, that is the diagonal of the Kennedy key will be equal to root 2 times of B. So we'll find here the large area which will offer the sharing resistance. Here L represents the width of the hub. So we have sharing area is equal to root 2 times B multiplied by L. And if we use the square key in which the sides are vertical and L is representing the width of the hub. So this plane represent here the sharing area. So this sharing area will be equal to B multiplied by L. So if the side is kept vertical, that is in the case of a square parallel sunk key, in that case the side is kept vertical of a square key. In that case the area will be lower value as compared to the Kennedy keys. So since the resisting area in the case of Kennedy is more, that equal to under root of 2 times of B multiplied by L, and when we have the square sunk key, that time the area is B into L. So shear area increases and hence the power transmitting capacity also increases. So Kennedy key is also used for transmitting the large power. Again for heavy duty we are going to use the bath key. In that case also the key races are made both in the shaft and the hub. The cross section area is slightly modified as compared to the rectangular section of a sunk rectangular key. So it is just a modified rectangular key. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.